This is awesome. So, oops. Thank you for coming to Serverless Toronto User Group Meetup. For those who are first time with us, like we normally 80% of our meetups are hosted at Myplanet. And then we started like in February 2018 registered, but first talk was here in May. Everything is recorded on YouTube except the last meetup because we did not want businesses to be spooked by oversharing information. So, how do I go next? So there is so many cloud groups and everybody's in the cloud. So I just wanted to explain for those of you doubting, if you're not in a good place, that we look at the cloud a little bit differently. Like it's not about the service, it's about the mindset. It's about not managing applications that they're not built. And the quote came from Gregor Hochhead. This is the author of the book Enterprise Integration Patterns, who is right now helping government of Singapore move into the cloud. So you'll have the old slides. Each of the pictures is clickable, so you can watch the videos or read about migration into the cloud. And then so that's about the group itself. But why we do what we do things? We started as serverless development full functions as a service, but before you knew, we ended up integrating and gluing other people's APIs, which enabled us to focus more on building good products and MVP. And then because there is less service to manage, we became aware of the importance of the front end. So we are really nicely tied with those user groups on the front end. We even had, I think, one meetup organized with Jamstack Toronto together. And then our overlap is really lean, like doing something fast. It's a promise of a Scrum or Agile. So I tend to throw definition that serverless is new Agile. You may disagree with me, but that's what I like to believe in. This diagram and the thoughts is from the Lean Product book by Dan Olsen. He runs the Lean Product meetups in California. They're awesome. They're also recorded. You can learn tons of stuff on how to build good products, where we are just one small piece in that diagram. And then like this meetup tonight, I'm really honored. It accidentally we came up to have this meetup. There are people from Myplanet with us here. So how it started, why I'm excited about this meetup. They were our hosts. They just gave us a house to let others talk about serverless ideas. And then Shelly, he told you before, while attending meetups, he's a host, he started applying them on his own project. So one of the projects he's going to be discussing is using serverless with IBM on OpenWhisk project. But that's just one part of that. So we had then another accidental visit of Amazon talk about DeepRacer, and I think Mohammed got excited about that. So Myplanet registered a team to compete in DeepRacer. So what happened then? It didn't stop there. He won in Toronto, and then he went to Renven to compete over there. And he's going to talk to you tonight about that experience. But it didn't stop there either. So it motivated scientists like George to work on machine learning algorithms to improve them so they can be even faster and do better reinforcement learning. But it didn't stop there either. So what happened? This place is rock solid in content management. And last time we had this meetup, we were trying to help businesses integrate with existing products they have. And one of the topics that Shanley and Andrew were working on was Headless CNS, but it was not recorded. So there were two approaches presented. Shanley doing whiteboards. People just dropped. It was just a deliverable presentation because it comes from the experience. Then their mindsets, it's a serverless mindset they applied to what they knew and gave back to the world. So I'm really excited to have that recorded. So why? This is really philosophical. So I believe. So I personally believe that humans always wanted immortality. So this is philosophical. Don't laugh at it. But in a way, the human race has achieved immortality. We are not there forever, but the knowledge and the ideas keep jumping from one to another, meeting and mating and growing. So this is just a period of 2 years, but the idea of them hosting us jumped onto one person, he spread to another team, then they gave back to us. So it's we are here making ripple effects, but then we are helping one another. In this world. So that's what made me excited, that something that just hosting became learning. And I'm so excited to give the mic back to them so they can teach us how they're applying serverless and use serverless mindset. So that's about this meetup itself. So we would not be here without our sponsors. Again, Myplanet, that happens to be talking tonight. Thank you for doing that. Like I was doing the research why I like this company, and like this is politically correct definition of B corporation, but there is another TED talk that recently started. It's talking about the companies that don't put profit first, but people first. In the long run, they last longer, and they like they become better in the long run for society, for their people, and more profitable eventually. And I think I'm outsider, but I believe you have that culture, putting people first. Another sponsor, it's kind of implicit sponsor, but from the almost beginning, like 2018, they started giving us free books. And every month, from month to month, money is giving us books. So tonight, you're really lucky because you have good odds, and we have 2 titles left. So we're going to give away everything they wanted to give us. So 2 winners will get one of these 2 titles. Next year, we're going to change format. Probably, instead of me picking titles for you, we're going to allow you to go on the Manning website and register for the title you want. So it's going to be, we'll figure that out. And instead of me giving these raffles, we're going to probably have an app, SMS number to text, so they can upsell you later. I'm kidding. We'll make it more modernized. So that's for me. I would like your input on the future talks. Like this is just what's cooking in my head. I removed the dates because we keep shifting the dates. So we were supposed to have a event recap this year, but presenter Jonathan wanted more time to prepare better for in-depth serverless edition. So you did hear him talk at AWS meetup last week, but it was a part 1. Next month, he's going to be talking in depth about what happened there with some examples. So I'm excited about that talk. Then at the PyCon Canada conference, like I met a couple of the guys, they're going to be talking about machine learning. So first one is using Python for serverless, using Zappa framework, which is not written about too much, but then he spices it up with machine learning. So it's a beautiful talk. So I asked him to combine his 2 talks from PyCon Canada into one, from PyCon meetups into one. Then there is a book by Manning that's going to be written by Jonathan. The book is in progress. He's going to be giving us overview of a PySpark cross-cloud, not going to be tied to one cloud vendor. And then like this is like, you throw in this what you want. I forgot to tell you, I'm also talking to Pivotal, because that I'm no longer working with the Amazon partner. We're going to bring more talks from other clouds. They have a good serverless story to tell. We did not firm up the date, and I forgot to put it last night, it was late. BigQuery is becoming really popular, and then I keep telling you about the Joe Anderson guy. Like that is a guy I admire. Like he created 4 businesses in 3 years, all using serverless technologies. So the last business is a big one. It's an insurance company. And looking at his architecture, he used BigQuery and he used Fivetran to move the data of Amazon Cloud into the Google Cloud. So I'm trying to reach to these companies to send us somebody to teach. So that's, I think, for me. Tell us why you came here, and then we'll proceed. Thank you.
All right, so we're going to switch up the order a little bit here. I'll get started. I have a couple of talks, and then we're going to hand it over to the DeepRacer folks. Sorry, moment. Okie dokie. So yeah, hi everyone, I'm Shanley. Please feel free to interrupt me at any point. It's a very small crowd today, so we can have more conversation. I'm gonna do this lightning talk style because I think it's a little bit more engaging and a little bit more digestible. So if you have any questions about the actual and specific tactics, please do stop me. Sorry. Oh, I guess this thing doesn't work. Google Slides. All right, so serverless at work, 2 case studies of production projects. What I'm about to talk about is actually 2 projects that we have at Myplanet that have reached production and have been in production for a while. I want to talk about their architecture, the concepts that inspired them, and then how they've worked out in the end. So the 2 I'm going to be talking about, the first is a B2C e-commerce website, and that's the Headless CMS one that I referenced in our talk last week. And then I'm going to be talking about an enterprise retail platform because I just love the juxtaposition. One is very relatively small. One is a huge enterprise and how you can leverage serverless there. So B2C e-commerce. So our client is an innovative biopharmaceutical company, and they're focused on the development, manufacturing, and commercialization of organic, sustainable, plant-derived, cannabinoid-based products. And that's the key part of what introduces this problem. Because they are talking about cannabinoid-based products like CBD and the like, they actually have this problem that very few out-of-the-box service providers are willing to work with them, specifically their payment providers, which becomes a very big problem for them. I mean, a lot of you may be familiar with the idea that if you're doing e-commerce nowadays, especially B2C, you don't really want to be rolling it yourself. What you want to be doing is going to Shopify, you want to be doing that route. But they could
roll it yourself.
Exactly. So yeah, that being said, we need to roll a custom e-commerce solution for them because of the fact that they can't work with other people. And this being serverless, we're going to do it in a serverless way. We're going to leverage Jamstack in order to make this as low cost to develop and to maintain as possible. So the tech stack that we use in this project is actually Gatsby. It's centered around Gatsby. I'll tell you a little bit about what Gatsby is. Gatsby is a React-based static site generator, meaning that when you actually program your sites in React, you can run a Gatsby compilation statement and it actually generates static markup that you then host with whatever you want, like S3. And then when you load those sites, they're very fast to load because there's no rendering, they paint very fast, and then React gets bootstrapped on top of that. So it becomes a single page app after you load them. It's actually a really nice framework if you haven't used it before. The CMS that we use in this case is Contentful, but you can sub in your favorite headless CMS. Contentful is one of our partners. And I'll be going a little bit more into our integration with them in just a moment. Our e-commerce engine with Molten, they are an API-first e-commerce engine, meaning that they provide all of the primitives that you need, like carts and products, to roll out your e-com experience. And then their fulfillment partner, because this particular company actually has in-store inventory across multiple countries, so we need to manage that. There's a payment processor, the one that would work with them, which is PayU. And deployment is on AWS with all of the usual suspects. But I would say that you could deploy this anywhere. You could put this on Netlify, for example. But because this is I guess we have to worry about security and compliance. We wanted to have a little bit more control about those aspects of it, so we deployed on AWS. Any questions so far? Yes.
Yeah, what does the Jamstack mean?
JavaScript APIs markup. So it's like a serverless mentality, I guess.
So would you say that React is pretty much the standard now for everything that you're doing, that you're building?
I have no basis for which to say that because I don't pay attention to industry trends, but sorry, go ahead.
No, I was suggesting that we leave the questions for the end, so we
Okay.
cut out the questions
Okay.
if it goes off track.
Okay, sure, sorry. Sorry about that. I misspoke earlier. I'll do questions at the end. All right, so I wanted to touch on two aspects of the solution that make it, I guess, easier for people to use and illustrate the way that this is glued together. So this is the first, the rendering pipeline. I can use this for lazy. So we have Gatsby over here. This is your React site. Normally what you would do with your React site is, depending on what version of React you're using, you would load your content, for example, your products and your page content or what have you. The way that it works with Gatsby is that you actually initiate a build, and we have our CMS, which is Contentful in this case, providing content, which is fetched dynamically at build time. One of the things that we've done to make things easier, and I'll get a little bit more into this in the next couple of slides, is that we didn't want to have our content authors have to go and feed data into Molten as well as Contentful. So Contentful has this really neat functionality called Contentful UI extensions, where you can actually program a UI extension for the Contentful web CMS app. And in this case, it fetches Molten product data. So you can associate the styling information of Molten product with a specific Molten product and have just the pricing data, stock levels, everything to do with the e-com managed here, and everything to do with the presentation, the merchandising managed here. And then it feeds in this way, and then it goes to S3 and CloudFront. So that's an example of the rendering aspect of this application. I wanted to give another example just to give you some ideas about how you might approach this in terms of the checkout process. So one of the things that we've done is we've made the entire post-checkout serverless using Lambdas. So we have a pay-you hosted payment page. After we create the products, we create the orders and the carts using Molten. The hosted payment page calls home to a post-order set of operations. So we have Lambdas for updating the Molten's order status, notifying a fulfillment partner, purpose, and generating order confirmation emails. And then using webhooks to further orchestrate things. So when our fulfillment partner tells us, oh, this order has shipped, we can then go back and further update more order statuses. So this is probably understandable to everyone, and I hope it's not new, but this is the idea. The entire site is running without a head. All right, so a few gotchas I want to call out for you if you're going to be doing this e-commerce thing or headless CMS. The first thing, internationalization. You want to be careful how you structure your content. You want to be able to easily leverage the same system for internationalization across all your content. So what I suggest is that you treat your Contentful CMS as the single source of truth for all content that will be rendered, and then reference other data from other third-party applications. That might be difficult if you have two separate teams, for example, merchandising versus product, that have to cooperate, but in that case, you have to do what you have to do. The second thing is authorship experience. A few different concerns. So the first is integrating third-party sources of content. In our serverless world, we often have, we have Trustpilot that manages the reviews, and we have Molten, which manages the pricing data, and we have whatever. So how do you integrate all those together? One of the things that we like about Contentful is that you can use UI extensions to have like a single view onto all of your data. And I really recommend that if you're going to be investing in the authorship experience, you do that. And these are tools you can take with you from project to project. The second is preview. In this new world where we're separating content from rendering, it can often be a pain in the butt. We leverage a service called Gatsby Preview, which actually provides its own UI extension. And essentially, whenever you go set content to preview in Contentful, it actually very quickly renders. I was amazed how quickly it renders a preview site for them, so they can go see what it looks like on the site. And then the third is hard-coded content. I really think that this was a pain point for us. We thought we could get away with it. We ended up not being able to move everything into Contentful if you can. Recompilation of the site. I will say that they are very slow to recompile. Do your best to push whatever can be to a fetch after the render. That's all I can say there. Because I want to keep this short. So the results are the site is live and accepting orders in multiple locales around the world, integrated with their in-store supply chain, and it's been running for a while. Any questions about that kind of stuff?
So you mentioned that the whole goal of using this stack is to cut costs and make sure that this is all was that target achieved? Like, is there a ballpark or like anything that you can share publicly about what is it?
Could you repeat the question?
Oh, sure.
Repeat the question.
So the question was, did we achieve our target and our desire of making sure that we cut costs and delivered on time? So we did run into some problems, but I don't think they're related to our choice of stack. They were mostly to do with some of our other implementation concerns. But I think overall the approach really did simplify it and allowed a team that was not a full stack team to go and roll out a full featured web application.
And then did you find, did you choose React or did Gatsby choose React and you said, okay, well that's what we need?
Gatsby is React based, and at Myplanet, all we tend to use is React.
Okay.
As far as like what you put in React and what you put as like a post-render pull, I mean, how do you balance the speed of the site with the compilation time stuff? I guess.
So I'll give you an example, specific example. We chose to have all of the content for a product in terms of its captions, all of its images, all that kind of stuff. We put that into the build, but things like the pricing, we actually make it so that you, and the stock levels clearly, you load it post render.
So all like the big stuff, you put in the bill.
I would say like important to like the business operations type stuff.
I mean, like kilobyte wise, like images and.
Oh, so I wouldn't worry too much about like the big stuff like from that point of view, because the fact that it's already static rendered, it's very unlikely that your site is going to have so much markup that it's becoming a problem.
But if you're like fixing a spelling mistake in the product description, you gotta wait for the whole bill.
That is
As opposed
correct.
to volume is real time.
That is correct.
Yeah.
It's a downside. I guess it's what we have to pay for actually getting the speed of a static site. I will say that on a lot of our newer sites, we are using Gatsby on some, but also Next on others. And Next is server-side rendering, which is kind of like you come full circle at this point, but it's a good balance.
Anybody else? Thank you for the first one.
So yes, I'll go very quickly on this one. I just wanted to give everyone an idea because this actually all started when one of Jonathan's talks, like essentially really got me going about like what could be possible for our enterprise clients. In the end, this is actually a business problem where we have a client where it's a large luxury clothing retailer, large Canadian luxury clothing retailer, and they were mired in legacy systems. I'm going to be saying legacy throughout this presentation, but I mean it lovingly. I mean heritage systems, because these systems have delivered lots of value and allowed them to grow over decades, but we'll say legacy. And they don't have an ability to innovate or deploy new e-commerce or omnichannel experiences. And this was their state about 2 years ago. So what did we do to help them move out of this? Lots of things, but I'm going to talk about the serverless aspect. So integration. This is actually an integration problem at its heart. This is actually one of the current state diagrams that we produced for them to kind of reflect back to them what was already going on in their system. And it's blurred for their protection, but also for your protection. It's not safe for work. You can see that all of these systems have like one-to-one connections flying everywhere. And this is kind of like the typical enterprise integration style. And they have multiple domain models at work, which is really the killer when it comes to like integration. You have your accounting domain, ERP, loyalty, CRM, all of these things working together. How do you make it so that you can build on this? So the solution, and by the way, am I doing okay on time?
You're perfect.
Okay.
Take your time.
Cool. The solution actually has two inspirations. The first is domain-driven design, and the second is a guy named Joel Crabb. So domain-driven design, they have this idea that you should identify what your domains are. You should identify what the concepts are that you want to protect and find a way to implement those in your code. But when you're working with legacy systems, frequently it can be difficult to protect your domain. So we actually use a pattern known as a bubble context, which is an isolated like innovation sphere, I'll put it, that is actually protected from the other domains using an anti-corruption layer. And I'll show you what that looks like very specifically in just a moment. The second thing is Joel Crabb's retail platform. Joel Crabb, he's VP Architecture, Chief Architect at Target. He actually has a model for a retail platform, and I'll tell you what that is in just a moment. So a bubble context allows you to create your own clean domain model. It decouples you from the underlying data sources and increases the pace of innovation over time. I'm going to show you what it looks like. So this is the architecture. A lot of their on-prem stuff is here, which is why it's truncated. But the entire idea is that our bubble context is this right here. It is a Mongo database with a fundamental data API, a read-only API over the set of retail primitives that they need, like carts, like products, whatever. And that is all aggregated and cached by a GraphQL server. It's actually Apollo. So the anti-corruption layer part is this part here, where we actually have a Kafka Connect host, which is reading from their data and streaming it into an event bus. And this event bus uses IBM OpenWhisk in order to transform the data and stream it into our databases. So they actually get very, very fast updates. They used to have to wait days in some cases. Now with data streaming in from all sources, it's on the order of minutes. So yeah, that's the bubble context that I want to point out. And I'll just go back here. I'll talk about the retail platform. it's a set of primitive APIs that represent the data that you need. There are other parts to his talk, and I really recommend you look up his talk if you're interested in this at all. It was like a revelation for me at the time. But the idea is we want to have a set of read-only APIs that represent our data. So in the end, that's what we did here. And we actually built what we call tenant apps. So the tenants are just applications that leverage our functionality. And we've deployed a few already with more to come. In fact, there's a large-scale rebuild of a lot of their stuff coming on right now. So this is kind of the architecture that we have. It's the streaming ETL ACL layer with a GraphQL Apollo fronted read API. So yeah, that's just to give you some ideas about how you might want to do like a large-scale project. And the platform recently reached a year of service, and this is like in production use, and we're continuing to build new apps and services on it. So yeah, that's that. Any questions?
Questions? Awesome. Any questions?
I noticed at the top you have like the Algolia search. I'm curious, how is it updated? Is it a one-for-one copy of the database?
No, it's not. So our update functions actually both update our Mongo like database and write to Algolia. So our ETL is to like multiple targets.
Okay. So in this case, is data flowing one way? Like it's coming from the legacy systems?
Yes.
And this is like analytics, viewing, business intelligence, that type of stuff?
It's actually other applications as well. So for example, their consumer application, they have some other like, I don't want to go too much into it because I don't want to reveal the
But
claim.
like nothing's going back to legacy.
Nothing's going back,
Okay.
and that's been one of my SERP points. The vision of this was bi-directional.
Right.
It was an event-driven system. Right now, it's just streaming ETL. But when we start getting things going back the other way, then it'll truly be an event-driven system.
Cool. Next.
All right.
Amazing.
Thank you, guys. I'm gonna pull up.
This is exactly that idea, Sharon, where Jonathan took. Yeah. Wow. I'll rewatch this recording.
All right. Here you go. Thank you.
Hi guys, how's it going? Thanks for joining us. So Mohammed and I just came back from re:Invent 2019, and we participated in AWS DeepRacer Championship at re:Invent 2019. We wanted to share with you our journey to this whole DeepRacer thing and give you an update on the result. Just for a show of hands, who has worked with DeepRacer or played with DeepRacer here? Who has heard about DeepRacer before? Okay, cool. So just give you a brief introduction to DeepRacer. It is a 1/18 scale race car. It is driven by a machine learning model called reinforcement learning. It is powered by AWS SageMaker and RoboMaker, which are both serverless. So I think I will get started with how do we get started with this whole thing. So just a brief introduction. Mohammed and I are both AWS certified solution architects, but we have no prior experience with machine learning. And in July 2019, there was a meetup happening here by Serverless that is a talk by Alex from AWS on DeepRacer, and thanks for whoever has made that happen. After the meetup, we discovered that we're really interested in this thing. We want to learn more about machine learning, so we launched an internal channel for collaborative learning. That happened in July 2019. Fast forward to October 2019. We went to AWS Toronto Summit, and we were actually able to snatch the #1 and #4 spots at AWS Toronto Summit DeepRacer League, which granted us a chance at re:Invent 2019 championship, competing with competitors from all around the world. Just a brief introduction in some preparations we did for the summit and re:Invent. for whoever is interested in maybe getting started with DeepRacer in 2020, I would say there's a lot of teamwork involved. We had help from a lot of our colleagues from Myplanet. And what we have done is kind of like an iterative modeling where we try new ideas, we make mistakes, we come up with new ideas from the mistakes, and we always ask for feedback, second opinions. We do log analysis, which is a technique in DeepRacer. As you can see here on the screen, it's kind of silly. But we iterate again, because we never know which one is our winning model. This is training all on the cloud, where eventually at the summit, you will put in the model in the car, and the model will drive the car itself. Before reInvent, we actually built our own track in the very secretive basement. Thanks for Trishma here, who is leading the effort. We found there are so many benefits in building our own track, such as it is cheaper than printing. It is reusable, it's easy to customize, and we had this brilliant idea, which is projecting the track on this wall right here, and it made it much easier to build our own track. I know a lot of people ask us, what's our secret in winning the Toronto Summit? We have the secret here, but it will be a little bit hard to explain if you haven't really worked with DeepRacer. So I think we'll just leave the secret in the slides and for you to go back and maybe review if you're interested. So fast forward all the secrets and let's hand the mic to Mohammed.
Okay. Okay, thank you guys. Yeah, the secret is kind of not that much of a secret anymore, but basically it was just about us using some models of like accelerating the car when it goes through straight lines. So part of DeepRacer is you train the car to, through a reward function of how it should act when it's going around the track for training. And one of the secrets that we did is just give it more incentive if it's going along a straight line so that it goes faster. So there are different strategies and reward functions that you can work on to make it go faster or more stable, I guess. So I'm sure everybody is excited to know like how we did it at reInvent. So as Willie was saying, we won the championship in Toronto. That gave us a ticket to go into the finals. So this is how the setup was for the finals. It's quite huge. So the venue was the MGM Grand Garden Arena, which is a place that takes 17,000 people usually. And they have converted that into 6 separate tracks, as you can see, plus a couple of mini hands-on booths that helps introduce people to the technology, etc. They also had another venue where Amazon was holding a DeepRacer expert boot camp over a couple of days to give more specific advanced talks to people who are really interested in DeepRacer, who wanted to improve their skills for next year. So the schedule that we went through was pretty tough. On Monday night, they had 3 more winners who would try their DeepRacer skills on a physical track. And then that brought up the total number of racers to 64 from all over around the world. So what Amazon did is quite big. They flew every winner of every summit that they had around the world. I forgot how many, like 20, 23 maybe? I forgot the number. And then they also had virtual races, and they had about another number of winners who won the virtual races or who had accumulated enough points to be like in the top X number of people. And then that was the 64. And then we all got to race on a few of those tracks on Tuesday from 64 down to 16. And then on Wednesday, they got the 16 to race again in a double elimination. So you race against somebody, then even if you lose, you race against somebody else. And based on that, people trickle down to the winning spots. So from 16 down to 3, and then on Thursday morning, just before their final keynote, they had another race that determined the one single winner. So how did we do? Well, we did well, I think. In Tuesday we qualified in the top 16. So our fastest lap was 10.852 seconds. As a comparison, the lowest was 9.056 by Sola, which she held the previous world record for the previous track, because they had different layout for reInvent 2019 than the layout that we used to train and race through the summits. On Wednesday, we hit our new record for us, 9.824, so almost more than a second less than what we had before, but still, it was a very competitive round, so we did not make it into the top 3. But still, we were racing against like topics, like people who do this for a living or they're studying ML, and as William said, we had no prior experience. So what we accomplished in the last few months has been amazing. Just if you want to know, like on Thursday, the winner was Sola at 10.230. And it's interesting because you see, like, we scored better than her the day before, and even she scored better the day before. But with DeepRacer, the car is trained online in a virtual environment that resembles perfect conditions. Like the lighting is perfect, everything is perfect. But when you take that training and you apply it in the physical world, you can expect any number of things. So based on the track lighting, based on the shadows, the car can behave in a different way. And that was very apparent if you ever go back and see the last race on Thursday morning, you can see that the 3 winners who are supposedly the fastest, like the best of the best, also struggled with the last track because it was done on a different stage with different lighting, with different situation. So that was it. This is the final breakdown of the top 16. So this is us, this is Mohammed. I raced against Fumiaki, which ended up like number 2. Wow. So that was quite a, and then I raced again under Kai, who also almost made it there. So you can see that, these were the top 3. And as you can see from the flags, this is well represented all over the world. So, got Japan, Korea's, like any number of countries. So it was really a great chance to meet other people. And as I said, we still won because we were able to present some of our experience, like the fastness, like the strategy that I mentioned now, plus be on an expert panel. So we were able to engage with the community. We met racers from all over the world and formed new relationships. We were celebrated by the Amazon AWS Canadian PR team, and we were also featured in an IT World Canada article about AWS and DeepRacer. So overall, it was really a fun and learning and a good learning opportunity. And I guess that's what Amazon wanted this to be. It's a way to engage people with machine learning and get them interested and excited about it in this way. So what's next? I mean, if this all seems so good that you're interested, in 2020, Amazon is making a lot of changes. So the car that we use had 1 camera and no other sensors. Now what they're doing in 2020 is they're releasing a new car called DeepRacer Evo, which has 2 cameras, so it'll be almost like a stereo video, and a LiDAR sensor, which will help for object detection and avoidance. You are able to train more sophisticated CNN convolutional neural networks. There are more physical and virtual summits. You can even have create your own private leagues, for example, at your company where people can race against. It is going to get crazy. And this is just a link to the blog post that talked about these things. This is a quick video of head-to-head racing. So with the new cars, you can also have 2 cars racing against each other, which was not possible in the previous one.
DeepRacer trying to stick to the dotted line in yellow. Dotted line, of fast. Unfortunately, that wall right there on SageMaker Raceway, they're going to be a taxing experience for DeepRacer on that particular lap. That's interesting to see. Certainly use the width of the all-new track unveiled here at reInvent 2019 to their advantage. Some obviously trying to keep DeepRacer in the middle of the wide track and some are certainly trying to maximize.
So as you can see, it's quite fun, and I have one track that was dedicated to testing, the new car out, and that was it. Okay, any questions? Anybody feeling curious? Yes.
Your car had 1 camera?
Yes.
Wow.
So the old car had 1 camera, and with the new one they'll have 2, and you can train more stuff.
Like for example, I tried a couple of times to buy the DeepRacer, but they always push back and say next year or after 6 months and all those type of things, Like how did you get the car?
Also, as part of winning the summit, every top 10 winners in the summit, they will get a car. So we actually got the car just like, you're right, like it was delayed. We just got it like 2 weeks before we actually were going to travel to reInvent. So
you didn't get before to like...
No, so even before the summit, it was all virtual. And that's actually one of the things that they say, like sim to real, like between moving from simulated environment to a real environment.
It's completely different.
Yeah, it is different. So some of the models that would be perfect in the simulation would not be well, like, and some of them would not, fare as well.
Right. Do you use also for training the machine learning and all those type of things? There's a couple companies that they have an open source project for like gaming and all those kind of AI or machine learning. Do you use those, or do you use a special one from AWS?
So for DeepRacer, they crafted an interface for DeepRacer within AWS. So if you go to the manager's console, you'll find the DeepRacer. And what it uses in the backend, a number of AWS services. So it uses SageMaker mainly for the machine learning platform training. It uses RoboMaker for the simulation of the car and the physical environment and all of that, and uses S3 and Connect streams and other services as well. So it's mostly AWS. Although some racers have transferred that to using open source training and local data, so that they can train locally on their machine. I think Jorge was gonna talk a bit about what he's done there as well.
Yeah. And why do you think it's like AWS is pushing so much this like globally? Like, what is the main?
I think it's just to get people more interested in machine learning overall, because machine learning, there is supervised learning, unsupervised learning, and reinforcement learning, and they're focusing, like with this, you're gonna learn more about reinforcement learning, but then of course you're gonna be intrigued of like, how else can I apply this? Or what are the different, usage of machine learning? And the idea is that they just want to get more people more interested. And I think there was a video that we shared in a different talk that talked about how did DeepRacer come up in the beginning. And I think it was internally something within AWS. Yeah, you can talk.
So AWS DeepRacer was announced last year at reInvent 2018. So if you watch the announcement video, they will tell you like why did they come up with this idea, why is there a leak? And if you look at the keynote this year, there will be more about machine learning. In the keynote, you can obviously see machine learning is a big area for AWS right now.
How long took you guys to like basically start using machine learning?
You mean with this?
Yeah, like for example, basically, yeah.
Yeah, I mean, when we started looking at this, they had the Udacity scholarship as well, so some courses. It didn't take long. I mean, we started maybe in a few weeks from the first time we started. We got going.
Yeah, we started in July from the Serverless meetup, and then we went to the summit in October. So, yeah.
Yeah, so we started late July, 1st October, August. So in 2 months, we were able to go and win the summit, and then another couple of months to kind of work more on the reInvent.
Congrats.
Thank you. Thank you.
Do you have the new car?
No, they did not give us that one yet. Not in production.
You're trying the new car.
No, we didn't have time to.
Do you still have the track in the basement?
No, we were asked to take it out. Because apparently they want to do some work there. Like, they won't be there. I don't know.
All right. Okay. Thank you.
All right.
Give me 1 second. Sorry, give me 1 second.
So I can say it's pretty addictive. So I would say don't try it until you're not ready to spend some long hours trying to figure it out. My wife definitely doesn't appreciate my interest.
Agreed.
So from my end, what I did was I joined Myplanet very recently actually as technical lead of the ventures team. So the ventures team is a bit like I guess bit of a marketing lead for Myplanet. So what we try to do is figure out what next technologies are coming to to the environment, and try to apply them, or try to figure out how enterprises may actually make use of them, both our current clients or prospective clients. And then we come up with ways. One of the ways in which we work is we come up with reference designs that demonstrate the use of those technologies, and then try to attract the clients to try them out. So from that sense, I understand perfectly, for example, the reason behind DeepRacer, right? So it's a lot easier to talk about machine learning if you have something to show for it than to just wave your arms in front of a client and say, you should try machine learning, come to AWS and figure it out. Right? They have actually done a very good job with making it easy for people to get started. Like if you try it out, you can watch a couple of their introductory videos that focus on how to reward or punish the behavior of the car. And then you can try it yourself. Like they even give you some sample functions, some sample reward functions that you can plug right in, spin up an instance of the machine learning process, and off you go. And it will probably do, not necessarily very well, right? Or it will do very well, but it will be very slow. But then from there, you can start building up. So I joined Myplanet, like I said, October, I believe. In October. So when I joined, I hadn't heard about DeepRacer. My boss, Greg, started telling me about it. He knows that if he tells me, I bet you can't do this, can you? Then I'll be all over it. So, and then on top of that, he said, oh, and by the way, we have 2 people here that are doing quite well. So, if you want to test yourself, maybe you can try and see what they've done. So that was like a lot of motivation, right? Like having someone in-house that is doing so well ends up really itching, right? And then, so I went into this. I did have some experience in machine learning. I did a couple courses in university, although 10 years ago, and then never touched it again. So I was curious about what I could contribute. And one thing that I remember about machine learning that was very important then, that I learned, is that you can always help the machine learning algorithm learn if you teach it something about the nature of the environment that it's trying to learn. So with machine learning, the car can do one of an infinite number of things, and the idea is how do you help the car search amongst all of those possibilities for the one that is going to give it the best result. And one of the ways of doing that is to constrain the environment. So with that and the fact that all through my teenage years, my dad was talking nonstop about how Formula One racers run tracks and how they can brake with the gearbox without touching the braking pedal, and how you can cut directly through chicanes, right, like consecutive opposite curves at full speed. All of those things that I remember my dad saying, and I would just roll my eyes because I had no interest in it. All of a sudden I had a way to apply it. So I was thinking, or the question was, can we teach the car to raise an ideal line? And an ideal line, as you can see here, at its very basics, is the fastest line that you can run through a circuit. So this is actually the next virtual track that is currently being raced virtually. So if you go onto the DeepRacer platform today, you'll see this track as the one that you have to train on. And that line in red is my best approximation of the ideal line. So what is the ideal line and how do you race it? So there's very basic rules, but it's really more art than science. So the best racing pilots in the world take years and years. It takes them years and years to really become good at racing an ideal line. So there's kind of 4 basic tenets of running an ideal racing line, and some of them are contradictory. So you have to be very skilled at balancing all of them. So the best thing, or the main thing, is that when you go through a curve, you have to take the widest possible turn that you can, because if you if you turn wide, then you can turn faster, right? If you turn very tight, then you have to slow down a lot. So that's relatively simple, but it's easier said than done. Another thing that racers tend to do, the best racers tend to do, is that they brake while they're still going straight. So they try not to brake when they turn. So they get all their braking done before they start turning. And when they start turning, they point right at the apex, which is the innermost point in the curve. And as you can see, this is a professional racing curve because it does a late apex, which means you have to slow down a little bit more at the beginning when you are about to turn, but you gain that back and a little bit more when you actually accelerate out of the curve, because you can accelerate out in full throttle. And then some of these things. This works really well for an isolated curve like the one I'm showing you here. But if you have another curve turning the other way, very close together, then you can't run the exit wide, because then you're going to have to slow down a lot on the next curve, right? So it's simple enough. But how do we actually do this? So I have a background in electrical engineering, actually, and there's one thing that I noticed at the beginning. So if you look at the ideal racing line, or my approximation of it, one thing you can notice quickly is that the curves are being smoothed out, right? The whole track is being smoothed out. And the curves that in red are a lot less pronounced than the curves in the, say, center line, for example. And in some cases, you can even skip through the entire curve with a straight line. So this looks a lot like smoothing or filtering of signals, which is something I used to do a lot in my previous life. So if you take the track as a signal that is changing in time, or in this case, as you progress through the circuit, and then you low pass filter it. So this is the same technique that people use, for example, to protect speakers from high frequency, like a subwoofer. You don't want to send high frequencies through a subwoofer because it can't sustain the load, it will break, it will burst. So you filter it out the high frequencies so that it only does the bass, right? So you can think of this problem in the same way as, the curve has some high frequencies. If you filter it out, maybe you can run through it smoothly. So that's what I tried first. I tried a low pass RC filter, which there's very, very common, simple implementations of it online. I have the code actually that at the end I'll show you a link to it if you're interested. And I did try it, and this is how it looks. So just like Mo and Weilin mentioned, there was a lot of trial and error involved in this. So what I found out is that it's best to filter on the space of the directions. So you don't actually filter the track itself or the waypoints, the XY coordinates. You first translate it into directions, both because one, you reduce the dimensions. So instead of having two numbers describing each one of the points, you only have one number. So it's a single dimensional signal, which is easier to filter. So you turn the track into directions, and then you calculate the change, the direction of changes, and then you pass it through the filter. And this is how it looks like after the filter. So this is actually the track itself, even though it doesn't look like it. It's just mapped onto a different space. And this is actually a very common trick for information theory and machine learning to reduce the dimensionality of your data so that you don't have to do a lot of work. And then you can map it back, right? So when you map it back, I'm not going to show you. I have an article that I'm going to refer to at the end of the talk in the last slide as well. You can see it there. But when you map it back, it looks really bad. Because when you do these kinds of numerical operations, you usually introduce artifacts. So you have to clean up the artifacts. Long story short, this was a good start, the low pass filtering, but I had to refine. So if you're going to try this, I'm not saying you should, because there's different approaches. Mo and Wei-Ling's approach is actually different from what I'm trying to do here. And because of that, I actually didn't have time to match what I was doing with what they were doing, so that to see if it could give them an advantage. Hopefully, we'll be able to do that next year. But you know, if you go the path of trying to run an ideal racing line, and one of the reasons to do that is because the path that I show you in red, in this case the path in blue, is actually tends to be about 10% shorter, which means you can take 10% less time to run it, and it also tends to be faster, or you can run it faster without getting the model too unstable. So ideally, you should be able to gain 10% on top of whatever you were doing already without using the ideal line. But I still have to validate that, or show that. So if you work on this, if you try to get an ideal line out of a track, I would suggest working always on the direction space. So again, this is the direction space, and this is actually the directions that map directly to the blue line at the top there. So you can see how I'm using constant directions for straight paths and linear direction changes for the curves. So, you know, the curve 1, which is on the, left side there, where the track starts, it's made up of linear direction changes, and it matches up with the last bit here. And then, you know, this discontinuity is because, you know, you're talking about angles, so as soon as you get to 180, then you go back to minus 180. But if you're interested in the details, I have details and I have code that you can take a look at. And like I said, the next step, of course, is to try to figure out how to translate this into a sensible reward function. I was hoping I could just match it to the reward function that Mo and Wei-Ling were using, but since they have a different approach, then I have to find my own reward function for now. But that's about it. Have any questions?
So do you get the race path, like the race course?
Yeah. So that's one of the reasons why this is possible, because every time a new track is released for racing, you get the whole set of waypoints. In fact, when you run the simulation, every time your reward function is run or is evaluated, you get the whole path in that reward function. So you can even print it. Even if it's not published, you can print it out, spit it out, and then reconstruct it and try the ideal path through it.
Cool.
Any other questions? 1, 2, 3, solved. Thank you so much. Thank you so much. Now you see why I was so excited about this meetup tonight, because 1 + 1 is not 2, not 3, it's 5. Like, I did not know where this is going to end up, and who knows how you will contribute, what you're going to build with those next, and when you put this all on the internet, how it's going to impact other people's lives. So, thank you. I'm going to do Manning giveaway draw now. Anybody does not have a ticket? Anybody?